Hello friends, in this video we will be discussing about the chapter 1 from science textbook for class 10 entitled Chemical Reactions and Equations. So let us first have the clear concept of reactions. Reaction is nothing but changes. Reaction is nothing but changes. Chemical reaction means permanent changes. Now it is not true that always chemical reactions are permanent changes. Some chemical reactions are there which can be reversible. That means they may get back to their original state. But majority of them once get changed can never be come back. So I think you have focused on the last statement that some chemical reactions are reversible and some are irreversible, but maximum are irreversible. Like burning of a paper, it is irreversible type of chemical reactions. So now, as the title tells that reactions and equations. Now what is the difference between reactions and equations? For example, I am stating a statement like magnesium ribbon when burnt produce ashes. This statement is reaction. If I write the chemical reaction like this formula, this becomes an equation. So statement is reaction and writing with a chemical formula is equation. Okay, the permanent changes may be change in state, change in color, evolution of gas. Evolution means production of any new gas, change in temperature. These are the changes. One of them may occur or all of them may occur depending upon the chemical reaction. Okay, the left side which are going to be converted or changed, that part is reactants. Reactants are going to be changed and products are the new substances which are produced. Okay. Before going to the next part, we must know the symbols for all elements. But I also agree that for the students of class 10, it is not possible for them to know all the symbols for all the elements existing in the world. So, to far extent, they should know the basic elements. So, next we have balancing chemical equations. Okay, balancing means keeping the number of atoms. Balancing means keeping the number of atoms of each element. Remember, keeping the number of atoms of each element before and after the chemical reaction constant or same. But it is not necessary that while writing a chemical formula, we always must balance the chemical reaction. The chemical reaction may be unbalanced, that chemical reaction is also correct. But generally, it should be balanced. It must not be balanced. It should be balanced. Mind the statements. Okay, now, before balancing the chemical equations, we must know the basic rules of the elements. Like, if I say simply H, that means hydrogen element. I am not suggesting any atoms or molecules. Okay, I think you have the concept of atoms and molecules. So by writing H, I am not suggesting any atom or molecule. But when I write H2, it means that one hydrogen molecule. H2 means one hydrogen molecule. But if I write 2H, that means two hydrogen atoms, not molecules, because H2 is a molecule. So here it is only H, there is no 2. So it is only 1. So 2 hydrogen atoms. But here 2H2 means 2 hydrogen molecules. I think it is clear. Then we can go to the next part. So I have already told you that we must focus on keeping the number of atoms while balancing. So we will focus on number of atoms, not the number of molecules. So when I write H, it means one hydrogen atom. When I write H2, it means two hydrogen atoms. but I can never write H3 Because H3 is not possible, is not basic, is not stable. Mind it, H3 is not stable, is not possible. H2 is possible. 2H2 means 2 2s are 4, 4 hydrogen atoms. 2 1s are 2, 2 hydrogen atoms. 1 1s are 1, 1 hydrogen atoms. So it is 4 hydrogen atoms. So I can write 2H2, I can also write 3H2. It is also possible. But I can never write 3H3 because H3, the problem is with H3. That means we cannot change this number. We cannot change this number. It is fixed. Yeah, we can change this number, the left hand side number. So, and at the same time, it is also true that all basic, like H2, basic, stable, hydrogen has 2 atoms in its molecule, but not necessarily all elements, all molecule must have 2 atoms or 3 atoms. Magnesium molecule has only 1 atom. Remember, Mg is just a molecule because this a molecule of magnesium contains only 1 magnesium atom. Simple thing. These things we should know while balancing. Okay. Before balancing, first of all, we should check whether the given chemical reaction is balanced or not. If it is already balanced, then there is no need to go proceed. So this is the reaction. Zinc 1, zinc 1 1s are 1, zinc 1, H2 2 2, sulfur 1 1, oxygen 4 4. So this is already balanced. But in this case, Fe 3. So this is 1, Fe is 1, Fe is 1, Fe is 3. So unbalanced. No need to check the others. If one element is unbalanced, that means the whole reaction is unbalanced. Whole equation is unbalanced. So if I put here 3, then iron becomes 3. Oxygen is 4. Oxygen was 4. Here it was 1. So I am putting here 4 because I cannot put here. I cannot put 4 here. It is impossible. But I can put 4 here. I cannot put 4 here also because it will be in between. So I can put here 4. But by putting 4, oxygen is balanced. But hydrogen has become 4 2s are 8 and it was 2. So I must put 4 here also, so that it becomes also 8. So in this way it is balanced chemical equation. Next we have this famous chemical equation. This chemical equation represents photosynthesis. If you have not forgotten, this is carbon dioxide, this is water unite to form glucose, C6H12O6 along with oxygen and water. So this is again unbalanced chemical equation, like C6 only single C. That means you have to balance it by repeated trial and error. You will learn that 6 should be here, 12 should be here, 6 should be here, 6 should be here. So you have to repeatedly check it and check it. So one more thing, you have seen many chemical equations, they are writing these letters. These letters suggest the state, the physical state of the molecule. Like H2O, you have not put anything here, that means it is not wrong, it is right. If you have put here L, that means L means liquid. Water may be liquid, so it is right. If you put here G, water in gaseous form, that is water vapor, so it is also right. But you cannot put Fe as G because iron can never be gas. It is either solid or in high temperature it may be liquid. In high temperature it is very rare, but it is common and it is though impossible. So we should proceed. Now we have types of chemical reactions. Okay, combination reaction, as the name suggests, combination means combine, one or two substance combine, like calcium oxide, quicklime. You must remember these things. Calcium oxide, quicklime, when unite with water it forms calcium hydroxide, CaOH2, slaked lime. I am not checking whether the reaction is balanced or not because we are not discussing about balancing the chemical equation. Balanced or unbalanced, the reaction should be right. Natural gas, methane, CH4, methane, natural gas, when burning. Okay, one more thing, whenever you hear this word burn, you should understand that it is reacting with oxygen. So when natural gas burns, it produces carbon dioxide, water and heat. Okay, any reactions which produces heat, they are known as exothermic. Exo means out. They are producing thermal means temperature. They are producing heat. These reactions are called as exothermic reaction. One exothermic reaction which is always occurring inside our body is respiration, which suggests that C6H12O6 glucose, when burned or when oxidized with inhaled oxygen, it produces energy, carbon dioxide, water and heat. So this reaction is always going on inside our body. Now we have decomposition reaction. Decomposition means one substance is getting broken down. Getting broken down, like limestone, calcium carbonate, limestone in presence of heat or when it is heated, it breaks down into quicklime, calcium oxide and carbon dioxide, which is gaseous forms. It will go up. Calcium oxide will remain there. Limestone was no more because it will be converted. So when you apply heat, then only this reaction will proceed. Decompose, just opposite combination. Two things combine, decompose. One thing gets broken down into the two things. So another example of decomposition reaction is silver bromide. It is powder. So powder is solid liquid gas. Powder must be solid. When in presence of sunlight, it forms silver and bromine gas. So this is a decomposition reaction. Silver bromide has been broken down into silver and bromine. But this reaction happens only in presence of sunlight, and it is used in black and white photography. So in this aspect, it becomes a very important chemical equation. So now here comes electrolysis of water. Electrolysis is comprised of two words, electricity and breakdown. Electro means electricity, lysis, always remember, lysis means breakdown. So breakdown of water in presence of electricity, it is electrolysis of water. So here is the process. We have water, electricity, we are supplying electricity with a cell. Positive means negative means negative. Cation is positive, so cathode is negative. So this is cathode. Anion is negative, so anode is positive. In this way you can remember, anode is negative but anode is positive but anion is negative. So whatever, and these things are graphite rods. I have seen once that what this substance is made of. This type of question has come in the HSLC final examination. So students occasionally ignore these things. These electrodes are made of graphite rod. These are called as electrodes. This is negative electrode, this is positive electrode. So water is broken down in presence of electricity to hydrogen gas and oxygen gas. This is balanced equation. So two water molecule breaks down. Remember, two water molecule breaks down to give two hydrogen gas and one oxygen gas. So two hydrogen, from two water molecule we are getting two hydrogen. So more hydrogen, less oxygen. That's why you can see less space and more space for hydrogen, because hydrogen is being produced in more amount. Okay, in this video this much is enough. We are coming up with the next types of reactions in the next videos. Till that time, thank you very much.